I didn't want to forget, so got it done. We've got some more people coming, I'm sure, uh, judging by how many we get normally. So I don't want to start too early, but if you have a question or anything, so anytime that you want to ask it. Usually, when we get ready for a test, which is Monday and Wednesday, Thursday, I'm sorry, of next week, usually that's when I start to get the questions. So I'm certain if you don't have them, somebody else is going to have them later and get the ball rolling. Okay. Okay. So this week we didn't have a test. We had a day off. Uh, that can be good or bad, but it makes no difference. We had it, and that's it. Next week we have next week we have two exams, and you're going to find that they're fairly similar. I mean, a lot of the information on the lecture exam on Monday uh, covers the heart, and so does the practicum. Uh, one does it with text, the other does it with pictures, almost as always. So as you're studying for one, you're really studying for both. Now the week after that, which is the seventh week, there are no tests. We need to finish up everything. And a lot of it actually will be new still. And then go to the end of the eighth week, our final week, and then it looks like it's impossible. Three tests. We have a lecture test. We have a practicum. Both really overlapping material, though. And as you study for one, you'll find that you study for both. Then the final exam on the very last day is over all of the terms. I've given you lists of terms for L2, for L1. I will give you a list of terms for L3 when we get up to that one. But all of the terms from L1, L2, and L3 will be on the final exam with multiple choice text questions, and the proper answer is one of the terms. So if you know the terms, there's really no further need to really study hard. Just review and be sure that you understand what each term means. You should be having no trouble with that final exam. So 3 tests in 1 week, is that too much? I've never ever in summer had a complaint that caused any problem. And so I don't really think it does, and I don't think you'll find that either. Just in case you were worried. Okay. Okay. We certainly have every everybody here probably that's coming, maybe one or two more, but they can wander in. Now, let me ask one more time. You got any questions before we get going?
Charlie, is the final exam, even though it has all the terms from all three of the lecture tests, still going to be 100 questions?
No, it's 50. Yeah, you would think it'd be more, I guess, but it's only 50 questions to check that you still know from the beginning what we have been learning. Fortunately for the summer class, the beginning wasn't that long ago. For the 16-week class, the beginning was quite some time ago, and those people really have to dip back in their memory to reacquaint themselves with those terms. But there are 50 multiple choice questions, each with 4 or 5 answers, and all of the answers are terms that are on the list. No answer is on the list unless it's one of the terms. So if you know the terms, you pretty well know the exam. I sent you a list of material that would be included for Monday. Okay, and if you didn't see that, please check your email. Not that you don't, but somebody could miss it. I just got a call from an insurance company this morning that renewed a policy for me, and I didn't send them back the information, the signature page that they needed. So I'm sitting here feeling pretty darn stupid. So it's pretty easy to miss an email, but at least they got a phone call to me and an additional email, and I got it done. But I like to extend the same thing to you. That is reminders. Reminders.
Wait, Charlie, you sent out an email with a list of them? Or isn't it on the module part?
Yes, it is. You're right.
Oh, okay.
It's on the module. What's included on L2? I haven't got the module in front of me right now, but when I share the screen, that's the first thing I'll look at. You're right. You're right. I didn't send it out on the list. It's on the module itself. Okay. It's a good place for it. Okay. Okay, let's get there. Okay, so we're on. Besides Canvas, have you ever heard the word module? They make that up?
I taught it in my AP classes in high school.
Oh, well, it's been a long time since I've been in high school. So, and okay, we're at module 7, 5. I'm sorry. It's month 7. And I think when we looked at this at the beginning of the week or so, I was saying, looks pretty skimpy. Doesn't look skimpy anymore. But 4 of the items in here are practice quizzes. Okay. And those practice quizzes, I really think are quite important for you to get an understanding of what I'm going to ask and how I'm going to ask it. Okay. So please do look at the practice quizzes. Then there are review terms for L2, and I'm not going to open it up just to close it again. You can take a look at them. They include the terms that are very likely to be answers to the questions on the test on Monday. Monday's test is at 1 o'clock. I'll start it up there at that point. And then here it is as I was being asked, what's on L2? And I will open that one up. So this is the material. The digestive system, cross-section of the GI tract, serous membranes, urinary system, which we did on Tuesday, heart structure and pathways through it, we were doing yesterday. Labeling of the important structures of the heart. I'm going to revisit that today. Blood components that we'd covered. Certainly there are more components than we did cover, but the ones that we covered are the ones that are going to be on the test. Vessels as it pertains to the circulatory system. The lecture is entitled Circulatory System. And I still didn't change this. I knew there was something I didn't change. A list of terms you should know is located in Module 5, yes. But 2 practice quizzes, that should say, of course, 4 practice quizzes. 4 L2 are located in Module, again, 5. I've got to remember to change that today. Bugs the heck out of me when I forget to do something. Now, in studying, you have to go back to Module 4 and find our first lecture that covers that material, and that's the digestive system. Anything prior to that, higher up on the page, no. This was 2 lectures on 628 and 629. Okay. The material isn't separated when you open it up, but if you go from top to bottom, you will have covered the 2 days. And then on 630, I did the cross section of the GI tract, and you see they're both indicated as lecture material. So those are both not only fair game, they're expected on Monday. Then we go down, past all this P2 stuff, and we come to the urinary system, which I said we did on Tuesday. That bears some review on your part, at least when you study. Since we're not going to have another opportunity face-to-face, if this is monitor to review this again, I expect I will probably get a number of email questions sent to me. That's absolutely fine. Okay. Yesterday in lab, and lab is not supposed to be on this test. So the ear, the brain, the eye, no, but the heart overlaps. And the portion of yesterday's lab that showed the parts of the heart, I'm actually going to show you again today, but that's fair game for this test, the heart. The lecture on the circulatory system that I put on What's to be on L2 a moment ago, here it is, and it's definitely lecture material. The list of heart structures that you need to know would, in other words, be labels that would be applied to a diagram that I showed you, or that I will show you. And you have to pick out the correct label. And I'll go over that with you in just a moment. Now, the vessels above the diagram, that's strictly lab, not for Monday, but it will be for the following Thursday. So if you have time, want to take a break from studying from the lecture, then you can go right ahead to these vessels above the diaphragm and the vessels below the diaphragm, which I intend to get to today in our lab today, along with fetal circulation. This will not be on the test on Monday. This is lab material, strictly lab, strictly lab, strictly lab, okay? Strictly P3, P3, P3. Okay? Unless it's with hearts. If it has to do with the heart, you want to look it over and get familiar with it. We have a lecture today on the heart using PowerPoint. I hate PowerPoint, actually. I know some of you like it. I think Mike said he likes to scroll through it, but I don't particularly like PowerPoint. The commercial models, the ones that you buy, are so lame. but well, we're going to use one. Okay. Now, I want to show you one other thing, and I will send you an email. If for some reason, okay, I get busy to change that other line of text that I showed you a moment ago, and forget to send you this email, absolutely. Say, Charlie, where's the email you promised us? Okay, so what am I talking about? I'm going to go to Bio 11. I have it pre-bookmarked. I gave you this link to the anatomy page before several times. It's in your syllabus. Okay, and enlarge it a bit, of course. And coming down to Unit 3. In the regular class, we call these units, we don't call them modules. And Unit 3 is the circulatory and sensory organs. Sensory organs are the ear and the eye. And I'm coming down to heart and diagram from the board. Now, if you click heart, all you're going to get is a list of terms for the heart. You've already got that. I gave you that. Okay. You want to click diagram from the board. Now, I'll send you this link in an email so that you can get there faster if you want. Or you can get there and bookmark it for yourself. This is off of a chalkboard. Okay, long before we had marker boards. And this is a hand drawing, of course. I did it. And not the greatest artist in the world, but I think I can get the idea across here. And so here's the heart. And I'm not just pointing things out right now. I'm actually talking. Okay, I'm actually going to give you some information. Of course, you'll have this on tape later on. Here's the heart. The broad superior portion is referred to as the base. And the inferior part, the most inferior part, the point is the apex. What else have I got here? Well, I've got 4 chambers, one here, third one, and a fourth one. I've got 4 chambers. Okay. I've got 2 flaps of tissue, which are the auricles. I'm going to go through this in an orderly fashion in a second. Blood returns to the heart from 3 pathways. From the head region, here's the blood returning by the superior vena cava. It disappears to the posterior side of the heart and enters down here into the right atrium. This structure, this round oval structure, is the opening to the superior vena cava in my drawing. So if that were labeled, it would be labeled superior vena cava as well. Down at the bottom, coming from the lower part of the body, is the inferior vena cava, bringing back deoxygenated blood. Okay, deoxygenated blood, and blood that probably doesn't have as many nutrients in it as it had when it left the heart. It comes up behind the heart and enters here, pretty darn close to where the superior vena cava is to be found. In fact, if you had a probe, a metal probe, and stuck it in the superior vena cava, it would come out here, and you could hook down in here and come out at the bottom. The third return of deoxygenated blood to the right atrium is through this small hole here. This is the coronary sinus. Now, I've got a couple of models to show you today that show you the coronary sinus in beautiful color. You can't mistake it. But just realize there are 3 returns into the right atrium, all bringing deoxygenated blood in the adult. Then the blood is forced down from this atrium to this ventricle, and over here this atrium to this ventricle at the same time. Well, let's just stay where we were. The right atrium, the blood is pressed down into the right ventricle. Okay. Next, it'll be time for the right ventricles to contract and push blood forward even farther. The blood that's being contracted or pressurized would really try to go right back where it came from, through this valve. This is the tricuspid valve. Tricuspid valve meaning it has 3 parts, 3 cusps. The blood could easily pass through into the ventricle, but it can't pass back out during contraction. Contraction puts force. Force causes the 3 cusps to close and not blow backwards into the right atrium. Cannot blow backwards because you've got these string-like structures attached to them. These are flexible. They can fold downwards and out of the way when the blood's coming in. But when the ventricle contracts, they lock shut. These are the chordae tendineae. Now, that's not, sorry. I'm going to have to reduce the size of the page a little bit. Here's the chordae tendineae, which means nothing more than tendinous cords, and it shows right here. How many sets of chordae tendineae are there? Well, on the bicuspid side, also known more correctly as the mitral valve, there are 2. But on the tricuspid side, there are 3. 1, 2, and where's the third? Out of view behind or in front. We can't see it. Okay. We've got a 2-dimensional drawing and we've got a 3-dimensional thought. The chordae tendineae on both sides stop the valves from blowing backwards. That means the blood has to move forward by another pathway. Also in the ventricles, both sides, you have these pockets. These are called trabeculae carneae, which means literally meaty hollows. Okay. And these meaty hollows allow the ventricle to contract and expand without damage. Okay. The heart can be damaged if it's too inflexible. It can split. So these help out the trabeculae carneae. Blood now moves from the right ventricle, still deoxygenated, and it moves up into the pulmonary trunk. Here's the pulmonary trunk here. And it's back here as well. There's a small valve in the pulmonary trunk. Try to draw it here. It's got 1, 2, 3 little chambers. When blood tries to come back, it's always even want to go the way it shouldn't. When it wants to come back, it can't. It gets trapped in all 3 of these little chambers, which inflate like a parachute and stop it from moving backwards. The blood would remain there, but more blood coming in, being returned to the heart, going through this process, pushes it forward. The blood moves up the pulmonary trunk and divides into the pulmonary arteries. pulmonary artery here. The blood that is in the pulmonary trunk and the pulmonary arteries has not yet reached the lungs, which is its destination. Since it hasn't reached the lungs, it's not been recharged, it's not reoxygenated yet. Our diagram omits the lungs, where the recharging happens, where the oxygenation happens, where the external respiration happens. But once that's happened, the blood returns from the lungs to the left atrium. And there are 4 openings normally into the left atrium. These are called pulmonary veins. The pulmonary veins are carrying oxygenated blood. So here's an example of veins carrying oxygenated blood. You want an example of an artery carrying deoxygenated blood? Go back to the pulmonary trunk. It's definitely an artery because it's moving away from the heart. The veins, the pulmonary veins, are moving towards the heart. All veins move towards the heart. Okay. Here's the left atrium. I look at it when I see a model and I think of it as the most boring of the chambers. They're all important though. The blood is then pressed down at the same time as the right atrium contracts. The blood is pressed down into the chamber below, which is the left ventricle. It's worth noting that the left ventricle is the largest chamber of the heart. The blood in here will be oxygenated, having returned from the lungs. When the ventricles contract, both of them at the same time, it's quite forceful. We know what happens on the right side. This is the right side. Okay. Same thing on the left side. The blood is forced up. The chordae tendineae lock shut, and the mitral valve can't be crossed, going in the other direction. Instead, we exit here and start a pathway into the aortic artery, and in particular, the ascending aorta. This is the ascending aorta. Blood in the ascending aorta would tend to fall back into the ventricle once the ventricle relaxes, except they can't. Again, it has a semilunar valve. The pulmonary aortic semilunar valve has 3 cusps. They fill and they expand, and as they do, the more they expand, the harder they shut, and the blood can't go backwards. We've got 4 valves in the heart. When a doctor takes a stethoscope, they know where to listen and how many fingers away to the next valve and up or down. The tricuspid has 3 cusps. The semilunars both have 3 cusps. The only one that has only 2 is the mitral valve. Both semilunar valves have 3 cusps. And the blood exits up the aorta. It's technically the ascending aorta. Goes up in the first vessel off, just as it is in the cat and the human models, is the brachiocephalic artery. And here's the rest of the aortic arch. Now, what I did not draw in here is the common carotid artery coming off next and the subclavian coming off next, which is present in the model. This is where I stop every time I do this board drawing. So that there actually are quite a few terms in here. the outside of the heart, as you're touching it, and you've stripped away any and all membranes, the outside is the epicardium. It's also known as the visceral pericardium, visceral on the organ. The muscular layer of the heart, just underneath it, and thicker, of course, all of this. As you cut through a heart with a scalpel, everything you're cutting, it seems, is myocardium. You don't have to cut the space on the inside. It's just there. But the inside lining is the endocardium. Endocardium includes everything inside. There was a movie that I never got to see about people in some sort of like a spacecraft being able to go inside the human body to repair it. And they float around in the various parts of the circulatory system.
Does it have Bill Murray?
What?
Does it have Bill Murray? Or sorry, no. What was it? The actor from Ghostbusters.
Well, there's a bunch. Murray was in Ghostbusters.
Bill Murray, I believe.
Yeah.
Bill Murray.
Okay.
I believe that was the guy in the movie that you're referring to.
Okay. I never saw the movie. But Bill Murray, I'm surprised you saw the movie.
Well, I saw a little bit of it, but I remember it was Bill Murray in the movie. But
Okay.
it's cartoon animated, right?
Yeah, that's going to be on the test. No. Okay. In any event, if you could move around in a little internal spacecraft, you bump the wall, you bump the wall, you bump the cords, you bump the valve, you manage to peek in and get inside the next chamber. Anything that you can touch is endocardium. Okay. Although each part of the endocardium has its own name. Okay. That's my little picture. And I'll get us back to where we are. Now, that picture will help you more than you know on the exam on Monday. Okay. So do take another look at it. It's not the most artistic picture, but it's certainly satisfactory. Okay.
I already found the movie.
Oh, okay. What's the name?
Osmosis Jones.
Osmosis Jones?
Yeah, I don't know.
God, who's going to go and want to see
That's
that?
the movie. It's really funny, but very informative.
Okay, that's good. But if I had my choice of watching Osmosis Jones and Revenge of the Nerds, it would be the Revenge movie. Okay. And if you haven't seen Revenge of the Nerd, it's a cult classic. You need to see it. I know a lot of people talk about a cult classic being Rocky Horror Picture Show, but I was at a drive-in movie. We had drive-in movies, San Capistrano, and I jumped out of the car and walked home. It was so lame. Okay. Now, here's the heart lecture using a PowerPoint that was professionally prepared. So I don't have to apologize for myself, except maybe for choosing to use it. Okay. So here's the heart. Well, that's in pieces, obviously. When you run this PowerPoint on your computer, it converts to nothing more than a display, one picture after another. You can't fast forward it. Well, I guess you can up here. Yeah, I'm sure. Okay, the heart's two side-by-side pumps. When they say side-by-side doesn't necessarily mean right or left. It can mean top or bottom. One pump, follow the arrow, goes around the body. pumping blood to the parts of the body, all of them, and then going through a set of capillaries and bringing back deoxygenated blood for recharging. That's the systemic circulation. I gave you that yesterday at the end of the lecture. And then the blood, which needs recharging, is taken by the pulmonary circuit to the lungs, passes through the capillaries for external gas exchange, external respiration, and now is recharged and returns to the heart in the proper chamber in the left atrium over here. The chambers, they have nothing to do on us. The heart, normally about 10 to 12 ounces in size and about the size of a fist. Okay. The number of beats, you've seen possibly some of the people's submissions from the discussion. I've read them all, and people have beat rates. One person has a 45, and yeah, that would turn heads at the medical center. Most people have beats of 80 to 90, and it goes up higher than that and still is considered normal. I'm at 60 to 65 and have been forever. Okay. But using one of those average numbers, you can come out with about 115,000 times of the heart beating per day, which is amazing, you know. Nowhere near the 3 million new red blood cells being produced per second, but still 115,000 times, you wonder if you're going to wear it out. The heart is located between the lungs, behind the sternum. The area that it takes up is called the mediastinum. Mediastinum. I'm too used to pronouncing words English-wise, and I, for the longest time, pronounced it mediastinum. And I think I did that for 15 years. Why? Because I never heard the word pronounced. I didn't check it on Google, which I could have, but I never heard anybody pronounce the word until one of the nurses that was in the class said mediastinum. I bit my tongue thinking I better not tell her she's wrong until I check, and it's mediastinum. Okay, that's this area here that the heart sits in. Heart sits in at approximately a 45-degree angle, and it's surrounded by the pericardial sac. Pericardial sac is in white here and has several layers, not shown, but the pericardial sac is for protection of the heart. There's a fibrous layer on the outside. You have to come across from here, this fibrous layer. Then you have a cavity, the pericardial cavity. And then you have the visceral pericardium. In the lecture I gave you previously, I properly called this also the parietal pericardium. This down here, the visceral pericardium, which you can't separate from the heart itself, and the space in between with lubricating fluid. This is the pericardial cavity itself. When we look at the layers of the heart, the outermost layers, and this is artistic rather than realistic, the outermost layer is the epicardium again. Okay. The epicardium, a moment ago I told you it's also known as the visceral pericardium. Then we have the myocardium. In order to see that, we have to cut the heart. So it's cut across here. And on the edge, there's all the muscle, cardiac muscle, some of it here. And this is the myocardium. The innermost layer lining all the chambers and internal vessels is endocardium. This diagram at the bottom, somebody went to town with as many labels as they could possibly squeeze in. If I had to get a map out, or MapQuest, or Google Maps, I would not expect it to be this complicated. So let's just look at certain vessels. The ones that are important are listed. First off, arteries carry blood away from the heart. Said that yesterday. They're under high pressure. The veins carry the blood towards the heart and under low pressure, so they can't move the blood as well. The pulsing of the parallel running and touching arteries causes pressure to be applied to the veins, and that helps force the blood forward within the vein. Veins, remember, have valves that once the blood has passed a valve, like a ship passing in a lock, it can't get back the other way. Actually, that may not be a good example because in most locks you can go both ways, but you can't turn the ship around. They're never wide enough. Okay, the vena cava, number one. Okay, here's the superior vena cava and the inferior vena cava. From the upper body, from the lower body. Okay. And now, all the rest of these terms, just look them over if you want to, but none of the terms that I don't mention are going to be included on Monday. Look, they took the same one here and pasted it in again. Vessel 2 that's important is the pulmonary trunk. That's this one right here. This is coming from the right ventricle. The blood's entered the right atrium, gone down to the right ventricle, and now being pumped out to the pulmonary trunk. This is carrying deoxygenated blood. It's a good idea to ask yourself what kind of blood, deoxygenated or oxygenated, is in any particular vessel. This branches into the right and left pulmonary arteries. Blood that returns from the lungs returns by means of 4 pulmonary veins. Here's 1, 2, and the 3rd and 4th are dipping behind the heart, and they're going to meet over on the other side and empty the oxygenated blood into the left atrium. The flap-like structure that covers each of the atria is an auricle. This is the right auricle here. Looks like a cauliflowered ear. And on the other side, here's the left auricle. The auricles can expand and accept more blood in times that you're exercising. The aorta is here, number 3, and you see the aortic arch. It's nice here in the human that they also have included 1, 2, and 3. This is the brachiocephalic artery. This in the middle is the common carotid artery for the left side. And this is the left subclavian artery. This portion that is past those three that service the upper body, this portion is going to the lower body. And this is the descending thoracic aorta. Now, we have a lot of drawings and pictures of the heart that don't do it justice, and some that don't do it justice, but do have something important to say, and this one does. Here's the aorta. The aortic semilunar valve would be located right about here. It has three cusps to catch the blood that tries to go back into the left ventricle. As the blood tries to go back, why would it do that? Because the blood shot into the aorta balloons. The aorta gets larger. Take the pressure off of it, no more contraction of the ventricle, and it wants to shoot that ballooned fluid in any direction. Well, it'll have to shoot it forward, 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 forward. It can't go back because of the aortic semilunar valve. However, with a slight exception here. Remember, there's three cusps in the aortic semilunar valve. Two of those cusps have a hole, have a foramen. The third one is a dead end. We were probably thinking that they were all dead ends, but two of them are actually the start of the coronary arteries. And out of one comes this one. This is the right coronary artery. And going behind the pulmonary trunk on the other side is the left coronary artery. Here's the label for it. The third cusp is, like I said, a dead end. So the very first vessels, and you need to listen to me say this a little bit more intently. The first vessels off of the aorta are the coronary arteries, because the heart takes care of itself first. These go to the heart, all around the heart. Okay? They don't siphon off a great deal of the blood. The heart needs blood for sure, but not as much as the rest of the body. But the heart will take what it needs, its share, first, always first in mind. We have a total of 4 chambers, 2 atria on the top. No, we know that. 2 ventricles on the bottom. Okay. We have an IV septum that separates the left and right sides. I showed you that yesterday. I haven't seen a good picture of it today. So when I do, I'll show it to you again. Trabeculae carneae are the ridges inside of the ventricular walls that help the heart expand. Okay, so here's a better picture right away. Thank you. Superior vena cava, inferior vena cava. They're showing one other thing. This is not the coronary sinus. This is a scar tissue called the fossa ovalis that we'll talk about when we talk about fetal circulation. I'm going to leave it for now. Tricuspid valve, held in place by the chordae tendineae. Chordae tendineae held in place or anchored by the papillary muscle. That's a papillary muscle. That's a papillary muscle. That's a papillary muscle. 3 of them. In this case, actually 4. One's doing double duty. Go out through the pulmonary semilunar valve, pulmonary trunk, and the pulmonary artery to the lung. Come back through the pulmonary vein, to the left atrium, through the mitral valve, the preferred name, but it's also the bicuspid. You need to know that. Just when you're on the job and have occasion to use the word, use mitral. Here's the chordae tendineae, papillary muscle again, going out through the three cusped aortic semilunar valve into the aorta itself, with the brachiocephalic artery, common carotid artery for the left side, and the left subclavian. Down here is the descending thoracic aorta. Layers on the surface is the epicardium. The muscular layer is the myocardium. Between the two ventricles, we have the IV septum. Okay, so now we have a better picture of it. IV septum is myocardium. And then everything on the inside, all of this, is endocardium. I'm skipping what I feel that we've actually already gone over. I shouldn't have to go over it again. This is trying to show a bit about what the atrioventricular valves do. The atrioventricular valves are the tricuspid and the mitral, and they're going from an upper chamber to a lower chamber. Okay, so here the blood is up here, is up here. Now the blood's been pushed down. Now the blood's been pushed down. Okay. At this point, it's being pushed down on this side by the mitral valve. The mitral valve slips open and the blood enters the chamber below. The chamber below is the left ventricle, papillary muscle, chordae tendineae. Now, when blood pushes in to the lower chamber and the blood is trying to be pushed out to systemic or pulmonary circulation, the blood's going to push up against the valves. And as it does, it pushes them back, pushes them together. This becomes this. Barely can see it in the drawing. Here are the chordae tendineae and the papillary muscles holding them in place. This is the pathway of a semilunar valve. Okay, so we have a semilunar valve here, the pulmonary semilunar. And we have way down here the aortic semilunar. As blood goes through the semilunar valve, because it's open, okay, the ventricle contracts and the blood is just pushed up, and the valve cusps are just literally pushed aside. But then, when the contraction below stops, the blood wants to come back down. Gravity will help it. Pressure will help it, moving from a ballooned state. But it can't. It can't get back down because as it tries to come down, it's caught in these pockets. There are three. The drawing only shows two. But the blood fills the pockets and they completely close, one against another. So the blood has been moved along, can't go back in the opposite direction. When a person, I don't want to get morbid, but when a person dies, it's often the case that the heart fails and the blood does move in the wrong direction. Okay, and so that's going to be quick after that. everything I've said is repeated here. If I thought I needed to repeat it again, I would, but I really don't. I know that when you review, you'll read it again, and I don't think you'll have any trouble with it. If I did, I'd stop. Here's the circulation shown once again. From the vena cava and the vena cava, we enter the right atrium, move down through the tricuspid to the right ventricle, up through the pulmonary semilunar to the pulmonary trunk and pulmonary arteries. Return through the pulmonary veins into the left atrium, through the mitral valve into the left ventricle, out through the aortic semilunar valve into the ascending aorta, or it can also just be called the aorta. The upper portion that arches over is very commonly called the aortic arch. There's a YouTube if you want to take a look at it. It won't show you anything more, but it shows you in a maybe more palatable way. Okay, any questions? I am going to show you heart models yet. I definitely need to show you that, and but I'm glad to get that one out of the way. I don't like to use the PowerPoints. I've told you that, but I know most people grew up with PowerPoints and they love them.
Charlie, I have a question.
Thank you.
What is the purpose for the mitral valve only having 2 of the chordae tendineae?
The purpose, well, let's see how I want to answer that. Okay, first off, that's just the way God made it. I mean, am I chopping out there? There's no particular purpose. It works. It works. Now, the fact that it works is why we survive as a species, other animals too. It works, and there's no evolutionary advantage to changing it, apparently. Okay. So other than that, anybody trying to give you a reasonable answer better have some science behind them, because like I said, I feel it's that way because that's the way it developed and it works. So, do you have a better answer?
I don't. I was just curious.
Well, yeah, a lot of us are curious. I hate it when I get in a curious mood. I start getting on Google and looking up the craziest things, things that I always wanted to know. And now, for some reason, I can have some machine figure it out for me. And then I realized I didn't need to know it at all anyway, and I promptly forget it. But as far as something having a function, everything does not have to have a function. Your earlobes don't have to have a survival function for you, and I doubt that they do. Okay, the fact that you hear structure and function all the time, people rave about it. Scientists rave about it, but unfortunately, they can look and look all they want, and sometimes they can't find a function. Well, there doesn't have to be one. There doesn't have to be. Think of the earlobes. There does not have to be a function. If there has to be a function, well, the thing's got to darn well be there. But if it doesn't have to have a function, it can be there or not. Okay. I mean, what's the function of red hair? Okay. Same thing. Okay, so I don't have a classroom textbook answer for your question. Anybody else? Okay, I'm going to give you a break until quarter after. I want to thank the people who have shared their video with us today, and I really do appreciate it. It makes it nicer for me. May be more interesting even for you. Okay, so I'll see you at 2:15, and we'll finish off this week, the 5th week. Okay, bye-bye. Okay, we're back.
Hey, Charlie.
Hey, Charlie.
Howdy. Anybody think of a question in the meantime? Looks like Randy sent out the link to the diagram. Thank you. So you've all got the diagram. I'll still have to send out a letter because there's 2 or 3 people not here, and want them to have it too. Okay, let's talk about something I don't like to talk about: dropping the class. I don't think anybody here is in the position where they have to drop the class. Okay, that's rare that I can never say that. Almost always somebody needs to drop. You almost have to take them over to admissions and records by hand to get them to do it, to save their lives. But I don't see that with you. I looked at your scores. Scores vary from so many that are really good to so many that are on the borderline between very good and not quite so very good. But they can go either way. Okay, that's up to the individual, of course. And a couple of scores still in the definitely passing range. But here's the deal: the last day to drop is Monday. Okay. Now there's an exception to that. I'll get to it. But Monday's the last official day to drop this class. Well, we have a test on Monday, so take the test, see how you do. And if you're on the borderline or whatever, some people, they don't want a B. They'll drop the class as soon as they see they're getting a B. They want an A. They'll be in school for the rest of their lives. But you'll get to see your score on Monday. I've taken the test myself a couple of times now, and I cannot find any fault in the test. No duplicate answers, no incorrect answers, misleading answers, nothing. So when you get your score on Monday after you finish the exam, and there will be a Zoom meeting on Monday after the exam, so that we can go ahead with the lab and get you ready for that. Well, maybe it did or did not want to hear that, but that's what we need to do. After you take the exam, you'll get your score. Okay, it's not going to be adjusted. I will not have to adjust a point or two here or there, and there's no extra credit when we add up the score for the lecture exams. That goes on to the practical exams. So the score is a raw score, and it should be the accurate score. You have 3 scores already. I've sent them to you individually. If you don't know your score, go to the website, Charlie's website, Bio 11 scores. You can get your 3 scores there too. Worst comes to worst, you can email me and have me look them up. But I don't like to play secretary. So you got 4 scores on Monday. Add them up, divide by 4. That's an average. Okay, and that will tell you approximately how you're doing. If you're in the 80s, you're in a B. If you're in the 90s or higher, you're in the A. If you're in the 70s, you're in the C range. Okay, and how far are you into the particular range? Are you at the top? Are you at the bottom of the range? Are you going to be able to make it across? Or you think pretty much you're going to stay where you are? And then you would make your decision to drop or not. Okay, again, I'm not encouraging anybody to drop. I don't think there's anybody that needs to drop. In the event that you've had a COVID issue, either with yourself, you've been positive, maybe positive but recovered, etc., or you had to take care of somebody else who was sick, okay, or you had to calm somebody else down because they couldn't stand the pressure. I mean, they may not be sick with it, but they're sick of it. And if COVID interfered with your ability to get the grade you need or want, you can still get a withdrawal after Monday. You have to fill out a special form called an EW, extended withdrawal. Where do you get the form? Go to admissions, go to Saddleback College website, go to academics, go to admissions and records. You'll find admissions and records anyway. And look on there for the EW withdrawal. If you don't see it, go up to the magnifying glass at the top of the page and put EW withdrawal. I did it that way myself yesterday. And actually, I found that the best form available was that at IVC. So I copied their form. Doesn't matter. IVC, Saddleback College, are one and the same, really. Okay. And what does this mean? If you take an extended withdrawal, you have to tell them why. And that means COVID related. Well, if you have one of those situations that I just mentioned, you've got it. If you don't have one of those situations that I just mentioned, you got to be smart enough to make them think you do. You can write a sentence or two that says that you were impacted. They're not going to sit there and call a meeting or anything like that. They're going to approve it. The state requires this, and if and when it's accepted, I should say, then you have until the 30th of July, this month, to get it in. When am I turning in the grades? Probably the 22nd or 3rd of July. My grades will go in first. Okay, so you can actually wait and see what you get before you send this form in. The form will override any grade I submit, and it's as though you were never there. And neither is your tuition money. That goes no matter what, unfortunately. The only other advantage to an EW, well, first off, you don't want to have to do it, but my God, if it has impacted you, then take advantage of it if you think you will benefit. But the other advantage of the EW grade is that it does not count against you as having taken Bio 11. When you take Bio 11, not you, but somebody, and then they drop and they take it again the second time, that counts 2. You take it again for the 3rd semester, but drop and don't even get a grade, that's 3. As soon as you have done it 3 times, that is, enrolled in the course 3 times, you will be excluded from the course at Saddleback and IVC for a period of years. I don't know how many years that actually is. I think it's 4. So you don't want to get locked out. You can always go to another school, but the EW will not count against you. Okay, in that respect, it'll just everything disappears off the record. Okay, I could have just been talking to the wind here because it really doesn't involve anybody. But if anybody has a question, let's have it. Okay.
Marley, I heard you say that you submit the grades, or you're planning to submit grades on July 22nd or 23rd. But our final and last practicum and lecture exam is on the 28th and 29th. How does that work?
Oh yeah, they are. You're right. Yeah. Did you get scared when I said the 22nd?
I was
I don't
hoping
know.
you'd cancel the final.
A little too early.
I don't know, scared or excited was the word.
Yeah,
Okay.
I was hoping you were just going to give us all A's for it and call it a day.
That'd be amazing.
You know, I've had a class where I've had all but one person get an A. And you have other instructors look at you and say, how come you can have such high grades? My class doesn't have high grades. You must be too easy. That's what it is. You're too easy. And not that I'm too hard, or not that I'm not disciplined or anything like that. It's your fault. Well, so I don't tell them my grades anymore, uh, except I tell one instructor. She and I agree. Summer school grades are high. No, the final is as scheduled in the syllabus. I usually like to talk about them in terms of weeks. That'll be week 8 for us. Okay, yes. And if it's the 28th, you say 29th? Okay, that's when it'll be. Okay, so can't you got, I'll get it in immediately. Let's see, hang on, I can look at the calendar here. 28th is a Wednesday, 29th, Thursday. Now, how can they tell you that you've got to have your form in by the 30th when it's a Friday and you know the school is closed on Friday? They made a big deal about the school being closed on Friday. I'll talk to somebody over there. I think I'll have you, is it predated or post-dated to the 27th or something like that? Have it ready. And I can walk them over if I have to. Okay, for you. Get them there by the 30th. You can get them there by the 29th if we do it early enough in the day. Hey, you're not really thinking of doing it anyway, are you? I hope not. Okay, but I know one person might be having thoughts about it. Okay, necessarily. Okay, let's move on. Oh, I don't like that one. Okay, we had this lecture right here. Okay, and now fetal circulation and the vertebral model. I'm not going to do that today. I'm going to, the reason is fetal circulation is not going to be on your test on Monday. The vertebral model is not going to be on your test on Monday. They're going to be on the practicum. And they're not long topics at all. So I just don't think I want to clutter things up. So let me get the hell out of here. Where'd it go? Down here, turn it off. Gone. Okay, we'll certainly be doing that little segment. Okay, so instead, we're going to do the vessels below the diaphragm. These are both for Monday and for Wednesday. Mostly, however, for Wednesday. We did the vessels above the diaphragm yesterday. And now we have the veins. So we'll start with the veins because they're nice and blue and we can see them better. And here's the diaphragm of a cat, actually. But if I were looking at a human being, I'd have to be pretty sharp to know any differences. There is one difference. Here's the inferior vena cava. Now it's really running towards the heart, going upwards. But here's the inferior vena cava. Nobody in this class is going to have trouble with inferior vena cava, largest vessel in the abdomen. Come down and you would find the kidneys right here and a kidney over here. Well, the two veins that are coming from the kidney are the renal veins. The renal veins. Above the kidneys are two suprarenal veins, adding to the volume of the inferior vena cava. They're coming from the suprarenal glands. Okay. There are also suprarenal arteries we'll see in a moment, and the suprarenal artery and vein run side by side. The renal vein and the renal artery run side by side. And once you see it with the kidney in place, you cannot mistake it. Now, in the cat, the left gonadal artery usually joins from the gonads, whether it's the testes or the ovaries down here, brings the blood back and joins with the left renal vein. You're not having to give the term left or right, artery or vein. You're only giving the root word. In this case, it's gonadal. If you say left gonadal, I don't know how you're going to do it because it's punch the dot type test. Okay? But here it comes in. Where's the right gonadal? The right gonadal is not symmetrical. It's not going to come in here. Here's the right gonadal. Okay. Once in a great while, we find a cat or a human that has this left gonadal come in here, come opposite the right gonadal. But that's like one time out of 50. This is the normal situation. Keep following down. And now we come to a cross of vessels, red and blue. The blue are the iliolumbar veins, and the red that run right with them are the iliolumbar arteries. Ilio for ilium, lumbar or umbar for the lumbar vertebra. These are so distinct that nobody that I remember ever has missed them. But now we're going to split and go into the two legs. It's a little bit more complicated here. First split here and over on this side, not labeled, is the common iliac vein. The word common, you're going to get asked this. The word common means that two vessels unite or separate, either way, to form a larger vessel or to come from a larger vessel. And they retain the same name. Oh, where's the same name? Here's the common iliac on the left side. Move forward and it splits again to an internal iliac and an external iliac. Okay, so the external and internal iliacs, being veins, are both actually running up. They come together and make the common iliac. The two common iliacs on both sides unite to begin the vena cava. We do have one small vessel that comes straight down, and that's the mid-sacral. It's also called the middle sacral, the median sacral, so many different types of sacral, but sacral is always in there. And this is going out to the tail. Follow the external iliac out, and it will turn here to form the deep femoral, and here. Now to clear this up for you, because I know you're a little confused, this area in here is like a bowl. Think of a metal mixing bowl. I have a mixing bowl. Stick it down in there. Okay. Of course, it'll be the size of a thimble. Stick it down in there. There's a bowl. Okay. You're going into the true pelvis. Okay. The mid-sacral runs down the vulve, almost like icing, or cake mix. The internal iliac runs down because internal means internal. The external is still up on the top of the bowl, which goes around here and here. And then the deep femoral starts across the bowl. And occasionally I see it go all the way across. But I didn't draw it that way because usually you don't see it go all the way across the deep femoral. Now at this point, the vessel erupts from the abdominal area or into the abdominal area, and comes out into the leg. And the first part is the femoral vein. Femoral vein. It will travel all the way down to the ankle as the great saphenous vein. But a branch of it will depart and go to the knee. You don't get to see this in every specimen either, but on the test you will get to see it nicely. And that vessel going out to the knee or coming back from the knee is the popliteal. Popliteal. The text, I don't know if you read yesterday's, but you should find that it's exactly what I just said. Okay? Nothing new, except to remind you that what's in bold is what can be asked. Here's a diagram if you want to print it out that you can label for yourself. Now looking at the arteries below the diaphragm. Again, I'm skipping over the text because I'm going to say every word that's in there. Okay, so here are the arteries. Here's the diaphragm, the big vessel running top to bottom is the abdominal aorta. Let's go down, pass by these guys, and let's come to the renal. The renal arteries are paired with the suprarenals above them, just as they were for the veins. To make it easy for us and more relevant, we'd like to see the kidney in place. So you'll see that in a moment. Okay. Let's keep going. Now we have the gonadals. And the gonadal artery always is opposite the right and the left, are always opposite each other. Remember, the gonadal vein entered into the left renal vein most of the time. The gonadal here. Now on gonadal, if you know that this is a female cat, you're correct, of course, in calling it an ovarian vein. And if you know it's a male cat, you can call it the testicular artery in this case. Okay. Keep on coming down and look for this one. We found the iliolumbar veins. The arteries run right next to it. They're really kind of eerie looking and very easy to spot. So we got this. Let's work our way back up. This is the iliolumbar. Let's move up. Oh, we've got one coming off here. This is the inferior mesenteric artery, takes blood to the large intestine. Here's the gonadals again. the renals again, the suprarenal. But then above that, we have another mesenteric artery. It's the superior mesenteric. The superior mesenteric takes blood to the small intestine up here, large intestine down here. Quite frequently in regular dissection, they get broken either accidentally or intentionally by students who don't know what they are and don't want to deal with them. So they just get rid of them. Okay, now above the superior mesenteric, we have another vessel. It's the first vessel that comes out of the aorta. It's the celiac. The celiac. The celiac artery, sometimes called the celiac trunk, and the superior mesenteric make a V. If you were to take your hand and make a peace symbol or a victory sign, a V, okay, and then hold it with your fingertips to the left, you'd have it. The lower one is the superior mesenteric. The upper is the celiac. The celiac is called a trunk because it breaks into smaller vessels. The hepatic goes to the liver. The gastric goes to the stomach. The splenic goes to the spleen. The hepatic is very hard to find. However, the gastric is easy and the splenic is easy. The only ones I would hold you for on a good specimen. The hepatic, I would not ask you. Come down now to the iliolumbar again. Come down, and now it splits into each leg. The arteries split into each leg. But we don't have a common iliac artery. We had a common iliac vein. Okay. We have an external iliac artery going all along the side there, and there's no internal coming off of it where I'm pointing. There is for the veins. Instead, a little tiny piece of the aorta extends down farther, and then the internal iliacs are here. They're getting to the same place, different route, and here. And going straight forward is the midsacral. The deep femorals run with the deep femoral veins. And again, after the deep femoral, passing through the body is the femoral. To the knee is the popliteal. But down towards the ankle is the saphenous. Not the great saphenous, that's for the vein only. And the saphenous is for the artery. The idea, of course, here is to get blood to every part of the body where it's needed. There's a diagram for you to practice on. We're going to have on the practicum, not on the lecture test, we will have this model. Now, after the lecture test, as I said, I'll have a lab, okay, a Zoom lab. We did that last time. And I'll have Monday, Tuesday, and Wednesday to give you the last little bit of material and to rehearse all the rest of the material. Okay. So in looking at this guy, it's parts of him seem quite easy. The external jugular, that seems like a good spot. How about the aorta? Oh no, the superior vena cava, I'm sorry. Here's the superior vena cava. Here's the brachiocephalic. We have a small bit of brachiocephalic showing over here but we don't know where it ends, so it's not been pointed out. Here's brachiocephalic. Here's the external jugular. We haven't labeled these yet. We're going to, but not on this guy. Going over the shoulder, going over the top of the shoulder, is the subclavian artery. The subclavian is not labeled on this side. There's the subclavian. And then now come down to the scapula and humerus together. And I'm pointing in at the artery here, which is continuous from the subclavian. This is the axillary, the armpit artery. That's always on the chest. Once you get past that, get farther down, you're doing the brachial artery. On the aorta leaving the heart, here's the aortic arch. Here's the inferior vena cava down here. It's coming in to here, the right atrium, which is unlabeled. Here's a common carotid artery. When we follow it back, look, it's between 1, 2, 3 on the arch. A for the aorta, B for the brachiocephalic, C for the common carotid, and then S for the subclavian, which continues over to here. I think I told you, we call these the flat man models. They're my least favorite. I'd rather be looking at a specimen, but we do use them for a modest number of questions on your practicum. We can find the inferior vena cava running here, the abdominal aorta running beside it, at the bottom of the aorta, you have a vessel coming off. That was the inferior mesenteric that goes to the colon. The superior mesenteric is up here. Here are the renal artery and the renal vein. Obviously, they don't show all of the vessels here. I will not ask you the hepatic, I told you that. So we will, on the other hand, looking for the splenic. Here's the celiac trunk. Everything's diverging from it. And this splenic usually is seen on this side. Why? Because when we look at the model, the specimen, we grab the spleen and throw it over to this side so we can see the vessels underneath. But how do we know it's the splenic? Whether it's on one side or the other, the vessel travels to the spleen. So we obviously have to know what the spleen looks like, not just on a model, but on a specimen. And we will. Here's the femoral artery outside of the abdominal pelvic cavity. In the human being, we do have a common iliac artery. Usually I present that idea on separate days, and today I didn't. So let me sort of repeat for a second. There is a common iliac vein in the cat, which branches into the internal iliac artery and vein and the external iliac vein. In the cat, we don't have a common iliac artery. In the human, we do. We have common iliac artery, comes this way, splits, and then we have the internal iliac artery and the external iliac artery. On this model, actually, things are easier. The common iliac artery and vein are together. The internal iliac artery and vein are together. And the external iliac artery and vein are together. Running down the backside here is the midsacral. You're thinking, well, we don't have a tail. We may have had one. About 1 in 50 or so people are born with a tail. By a tail, I mean a nub that would extend to about 10 inches left in place. The doctors snipped that off immediately. Don't want a lawsuit. Okay. Now, looking at the leg. Okay. Looking at the leg. The saphenous vein, the great saphenous vein is coming down here. And here's the saphenous artery right next to it. These vessels are on the medial side of the knee. Here's your fibula, tibia, and femur. This is the medial side of your knee. Now they have the leg on or the other leg turned outward. And the popliteal, which is coming down here, and the femoral artery, okay, coming down, and they're on the posterior side of the leg. Posterior, take a look at this, and medial. Okay, so the last thing we're going to look at today, since I took away for the time being fetal circulation and the vertebral model. Now, I'm going to post that for you over the weekend for those of you who want something additional to study, but you're not necessarily expected to go there. Heart models and specimens. This, you'll notice immediately, oh, didn't we see this picture yesterday? Yes, it's been used in both topics. Okay. This is myocardium, the muscle mass of the heart. Endocardium, it's actually pointing to the papillary muscle, but it's all this internal tissue of the heart, endocardium. And the visceral pericardium is on the outside. That's also known as the epicardium. You need to know that one both ways. Visceral pericardium and epicardium. Here's the right atrium. I know I'm going fast because we did see this yesterday. The tricuspid valve, the right ventricle. This is the IV septum, and of course that's myocardium. Right in there. The apex of the heart, the pointed downward portion. Here's the large left ventricle. Here's the mitral valve. And the left atrium is way up here. Now the atria look fairly small. They can enlarge with the help of the auricles of the atria. Here's trabeculae carneae down at the bottom. This is a papillary muscle. This is an outcropping of the wall of the ventricle. Papillary muscles are only found in the ventricles. And attached to it is the chordae tendineae.
Charlie,
Yes.
the trabecula carne, is that entire area or just that one small hole that the arrow's pointed to?
Okay, this one, the trabeculae carneae.
Correct.
Okay, it's everything. I don't know if you see it like I do, but it looks like a bunch of tree roots that grow over rocks.
Yes.
Okay, all of that is trabeculae carneae. And there's more, because you're only just looking at a small slice into this left ventricle down here.
Okay, thank you.
Here's the aortic semilunar valve, way up here. Okay, now with a model of the heart, endocardium, the inner chamber, myocardium, the muscular thickness, epicardium or visceral cardium on the outside. A different model this time. Let's get our orientation. Here's the pulmonary trunk running right through the middle. On this side is the right atrium, and on this side is the left atrium. Each is being covered by the auricle. There's an auricle here. Okay. There's no arrow to an auricle here, but that's an auricle. The atrium itself is underneath it. Here's the superior vena cava. You're looking like, why is it arching over? Because blood's coming in, and it's coming into the top of the right atrium. Superior vena cava. This does not show the inferior vena cava. As I said, here is the pulmonary trunk. Barely visible coming off is a pulmonary artery. You'll be given a better picture if that question is asked. Okay. Here's the left coronary artery, and the right coronary artery is over here. Backtrack. This goes behind and comes out of one of the cusps of the aortic semilunar valve. Backtrack on the right coronary artery, and it goes under here and enters the aorta through one of the cusps of the aortic semilunar valve. Because the heart takes care of itself first, always first. You don't want to be confused on a model, and sometimes you are when you see it for the first time. So we need to see everything at least once, so we don't spend our test time trying to figure things out. The trachea is on the posterior side of the heart, and it's shown right here. This is the trachea. Okay, but we don't want to get confused with that. This is the superior vena cava. I've got it on the other side. You're looking from the back. Superior vena cava. And here's the inferior vena cava. They both empty into the right atrium. What else enters into the right atrium is blood coming back from coronary circulation. Those right and left coronary arteries spread out over the heart, and now the blood has to be recollected. And here's what recollects it, this large vessel here. A pocket behind, and then an entrance into the right atrium right here. This entire structure at the back of the heart is referred to as the coronary sinus. The opening into the heart is also called the coronary sinus. Coronary sinus gathers deoxygenated blood from the coronary circulation. These are pulmonary veins. They're bringing oxygenated blood back to the left atrium, which is over here now. The aorta is here. So just a different orientation that won't fool anybody if you bother to take a look at it. The right atrium is located not there at all. That's wrong. Here's the auricle of the right atrium. The right atrium is there. Nobody has ever noticed that. Okay, what is it covering? It's covering the right ventricle. I'm going to have to fix that one. That's page 7. I'm writing it down. Okay. I'll fix that one for you. If you find I made too many promises and don't remember to keep them all, just email me, please. I appreciate it. Here's the apex over here. This is the pulmonary trunk.
Charlie, so where's the actual right atrium on this model?
It'll be underneath the auricle.
Okay.
Okay, on this model, obviously in red is the aorta. Here's the pulmonary trunk. We're looking at it from the lateral or side. Okay. This large chamber is the left atrium. It's receiving blood that is oxygenated from the lungs. It's 4 spots here, 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 here. And I cannot tell you why they put that tiny little extra one in there, but 4 spots which we call pulmonary veins. These are the pulmonary veins. The main thing about this model is that you see the coronary sinus coming back and entering here. Okay, it looks like it's entering into the inferior vena cava, but both of them are entering here into the coronary sinus. Okay, the hand is holding back the pulmonary trunk. This is part of the pulmonary trunk also. This is carrying deoxygenated blood back to the lungs. When it's pulled open, you can see the pulmonary semilunar valve with its 3 cusps. They're in the inflated stage, so blood would not be able to pass through them in either direction at this time. Down here, chordae tendineae. Here's the start of the coronary sinus going all the way around. Here's the pulmonary trunk or artery. Actually, pulmonary trunk would be a better term here. That's on page 10. That needs to be changed. Here's the pulmonary semilunar valve. Here's the aortic semilunar valve. Up here is the the left atrium, receiving oxygenated blood from the lung, goes through the mitral valve here. Here's the trabeculae carneae, And then out is through the 3-cusp aortic semilunar valve. Okay. Auricles flipped open. We saw this one yesterday. Right atrium, right ventricle, over to the left ventricle, the IV septum down the middle, the left atrium. The tricuspid valve, the mitral valve, the chordae tendineae, they actually show better over here. The trabeculae carneae in here, on the inside of the wall here. Here's the pulmonary semilunar valve, 1 cusp, 2 cusp. Where's the 3rd cusp? It's down here, flipped out of the way. Pulmonary semilunar valve, blurry, but gives you the idea. You can't see the aortic semilunar valve here. It's off to the side right here, but you saw it just a moment ago. Aortic semilunar valve right there. Coming off the aortic arch, or the brachiocephalic again. Here's the common carotid, the left one. Where's the right common carotid? It's up here. It doesn't matter how the vessel gets there. It only matters that the vessel gets there. This is the left common carotid, and this is the left subclavian. Without using terms left or right, it goes A, B, C, and S. Pulmonary artery, backing up, pulmonary trunk. Pulmonary veins over here, 4 of them coming back in. On the posterior side, again, so as not to surprise anybody, the rib structure is the trachea. Here's the inferior vena cava. And this structure is the esophagus, which runs posterior to the trachea. If you ever had a short quiz and said, what organs are in the mediastinum? You would say the heart, a portion of the esophagus, the trachea, and you would also consider, in some people, the thyroid gland and the thymus gland. We haven't studied it yet in an infant. Do absolutely study that board chart that was passed around on the chat. Did everybody get a chance to get it? It's right here. Well, I don't know if you can see it, but you should have. How does that show up for you? Who got the link from Randy?
It's good. I can see it.
Yes.
Yeah, I can see it.
Okay, now when we sign off, can you still see it? Can you get it? You better maybe copy it down now, or you just have me send it to you. Okay, I'll send it regardless.
Yeah, you
Okay.
can still see it after. You should, after you click on it.
Oh yeah, after you click on it, you should go right there. But like I said, after we sign off, I don't know if you have access to that.
Oh,
No,
you
you
can
can't see the
save the
chat.
picture, but I think the link will disappear once you log off if you don't save it to your desktop or something.
Okay, well, it's easy enough. Diagram1.html. I'll just send it to you. I'll send it to everybody as soon as we end, which is now essentially. If you have questions to ask, for the good of all, let's hear them. If you have questions to ask just for yourself, I'm sticking around as I always do, and I'll be here until the last person's gone. Okay.
Charlie,
Yeah.
do we have an outline due by Monday? Do we
No.
have to finish the urinary by then or no?
No, by Thursday, you have urinary and digestive due. That's all.
Okay.
I
Thank you.
am going to assign, well, we've already done the heart. I'm just going to assign something on Friday. Okay. Next week, you have no tests. So I want to assign something that will help you with the new lecture material, which is going to be largely nervous system. And that takes a little bit of illustration to get it across. Okay, so any other questions for the good of everybody?
I don't know if my question is for the good of everybody, but I was looking at in the PowerPoint during lecture, there was a picture of the pathway of blood for the heart, and it had arrows in blue and arrows in red. And I just want to make sure that the blue arrows are the veins and the red arrows are the arteries, because I think I was getting a little tripped up.
No. If it's in the heart, you don't have a lot of named vessels that are arteries or veins. There was the status of the blood while it was in the heart. Was it deoxygenated, in which case it's going to be blue, or if it's oxygenated, it will be red.
Okay, thank you.
Okay. Okay, feel free to commence your weekend.
Thank you, Charlie.
Thank you,
Bye-bye.
Charlie.
Thank you, Charlie.
Thank
Bye.
you.
Sorry, Charlie. So red is oxygenated, blue is deoxygenated. You said, right?
Yes.
Okay.
Now, if you move ahead to the fetal circulation, when I post it for you, most people won't. They'll wait for me to do it on Monday Lab. But I don't like their color scheme on that. Okay. But it was fine for that PowerPoint that I showed you. Red, oxygenated, blue, deoxygenated. Stick with that. Okay.
Okay, thank you. Have a good weekend.
Bye-bye.
Charlie?
Yeah.
Hi, so this is Kiana. I emailed you before the class about the quizzes. So I think it's gonna be 4 of them. I'm just gonna send you the screenshots. I'm just gonna email the screenshots to you if that's okay with you.
That'll work.
Okay,
Yeah,
perfect.
I don't know why they'd be locked, but maybe I didn't put, I put an end date I thought was way on out there, and we passed it anyway. I'll look at it. We'll get it settled.
Okay, I appreciate that. Thank
Okay,
you.
thank you.
Have a great day.
Thank you, Charlie. Have a good one.
Okay.
Bye, Charlie.
Bye, Randy.
Have a great weekend. I'll
Okay.
see you. Do we have lab on Monday? We have lab, right?
We're gonna have a lab on Monday.
Okay, good. So I'll
If
see
we
you-
don't, it just makes it so much harder for you.
Yeah. Okay, cool. Well, I'll see you Monday.
Okay. And Taryn, you're going to go out on a 25-mile run. According to your post, it looks like you're moving around all the time. No, I can't hear you anymore. Sorry. Don't know why. You're muted.
I'm sorry. No, I do move around quite a bit, but I definitely don't run long distance.
Okay.
All right. Thank you. Have a good weekend.
You too.